Assalamualaikum. Today we are going to look into an FET transistor with 2N422 model. Okay, so this is the model of the transistor that you used in multisim for your lab number 8 and lab number 9. So for this transistor, let's say for example, the IDSS and the VGS off is not given. So you can use multisim or in practical to check how much is the IDSS and how much is your punya VGS off. In order to obtain the IDSS for this FET, the VG you need to set to 0 volt, and this one is your punya VDD supplied to the drain terminal. So in order to check the current for the drain, in order to obtain IDSS, I connect an ammeter to the drain. From the supply to the drain, you need to connect in series. So from this configuration, I already obtained the IDSS, which is equal to 7.892 milliampere. So why do I need to obtain all this IDSS and the VGS off? Is because in order to obtain drain current in the future, you need two information, which is IDSS and the VGS off. So you can determine this IDSS and VGS off using the practical or simulation multisim. So you already obtained IDSS. Now you want to know what is the VGS off for this transistor. In order to obtain the VGS off, you need to increase this supply, the VG, more negative. How do you know when it is already reached the VGS off? When the drain current here, which is this one, when it is already reached almost to 0, that is when kamu already reach the VGS off punya region. So for this analysis, I will not go to 0 ampere. I will just stick to 3.5 microampere. That is already small enough to consider the drain current is almost 0. So we can say that the VGS off equal to minus 4 volt yang di sini. Because kamu lihat di sini, the negative terminal is the one connected to the gate terminal. So since kamu already obtained the IDSS and VGS off, you can bias kamu punya circuit in the DC analysis circuit. So for this circuit, it is already, this is kamu punya example from lab number 9 for FET lab biasing and amplifier, but the difference between the lab 9 and this example is that the source terminal, yang source terminal di sini, I make it into ground. So dalam kamu punya lab, it is connected to VSS. So the biasing will be quite different compared to this one. For example, for this example, I ground the source terminal is because to make the analysis simple, so that you can understand from this and then you can explore more what if the source terminal is connected to VSS. Okay, so from this diagram you can calculate what is your punya drain current, the VDS, and what is your punya VGS. Okay, since kamu already obtained the VGS off equal to minus 4 volt and the IDSS equal to 7.9 milliampere, you can insert all this information to here, and then this one to here. So as you know that in self-biasing, VGS is equal to VG minus IDRS. So since VG is equal to 0 volt, then VGS is only equal to minus IDRS. So that's why, as you can see here, the VGS is equal to minus IDRS. So if you simplify all the equation di sini, then in the end, kamu punya current, you should have two current where ID1 equal to 1.179 milliampere and ID2 equal to 0.6143 milliampere. So based on these two currents, you need to determine which current is the valid current. So how to check this drain current is by inserting back this drain current punya value to VGS di sini, which is equal to minus IDRS. So as you can see here, the VGS1 is equal to minus 5.5 volt. Tapi kamu punya VGS off di sini is minus 4 volt. So kamu punya VGS di sini should not be more negative daripada VGS off. So VGS off is equal to minus 4 volt. So the VGS1 should not be more negative daripada VGS off. Must be less than minus 4 volt. Maksudnya bukan dari minus 4 volt. Macam minus 3 ke, minus 2, minus 1, minus 0.5. That VGS is valid. So as you can see di sini, in ID2, you have current equal to this value. And then you check in your VGS, kamu punya ID is only minus 2.89 millivolt, which is in the negative more than this minus 4 volt. So this consider valid. And then if you want to calculate the VDS, you need to apply KVL. So how to apply KVL di sini? VDD equal to VRD plus VDS plus VRS. So if you want to calculate VDS, you need to manipulate kamu punya equation where VDS equal to VDD minus VRD and minus VRS. So in the end, kamu punya VDS equal to 9.23 volt. So how do I ensure that my analysis is correct? So you can check all your analysis in practical or simulation. So as you can see di sini, the drain current here I got 614.3 microampere. But in the simulation I get 623.9646 microampere. So based on this value, I consider that it is almost the same. So I can guarantee that my analysis is correct. And then you can check again the VGS. So the VGS here in analysis I got minus 2.89 volt. And then for here, the VGS is equal to minus 2.933. So I consider this value still okay. And then for the VDS, I got 9.23 volt. And the VDS in simulation, I got 9.133 volt. So I have proof that my analysis is correct based on using simulation software. Since kamu already found out what is your punya ID, VDS and the VGS, this is only to bias the FET. So but in biasing the circuit, you can obtain your punya Q point. Sudah kamu dapat Q point, the important part is you want to calculate what is your punya voltage gain, and maybe if you ask, and maybe kalau kamu kena tanya dalam test to calculate what is your punya Vout. So it depends on the question. If the question ask you to calculate what is the voltage gain, then you need to calculate what is the voltage gain of the circuit. So in order to calculate the voltage gain di sini, voltage gain, you need to find out what is your punya GM. GM di sini is your punya transconductance. Okay. So how to obtain this transconductance punya formula is you can check on the previous notes where I have shown you what is the formula for the transconductance. So the transconductance is equal to this equation. So if you insert you punya VGS yang kamu obtain, and okay, itu saja yang kamu obtain, which is VGS. IDSS kamu dapat dari simulation. VGS off also mendapat dari simulation. So in the end kamu dapat GM transconductance equal to 1.096 millisiemens. Sudah kamu dapat transconductance, di mana pepakai arah transconductance ini is arah ia punya dependent source. Dependent source ini maksudnya this ID ia depend on value of GM and VGS. So if you look at this diagram, ia punya Vout is equal to ID RD in parallel sama RL. So apa di dalam ID ni? Apa di dalamnya? Vout is equal to GM VGS RD RL. Okay, so dari original this circuit, I have shown you on the previous lecture how to transform this circuit jadi equivalent circuit. So for this equivalent circuit, macam mana untuk dapatkan ia punya equivalent circuit is, if you look di sini, this RG is already connected to ground. So kamu tak payah buat apa-apa. You just follow the diagram where RS di sini and then RG connected to ground. So you just follow to ground. So di sini RD, if you look here, RD is connected to plus VDD. So in equivalent circuit, all of the DC component you need to ground. So you need to change yang VDD tadi, ia connect to DC supply and connect to ground. So similar dengan RL di sini, ia connected to VDD. So you need to ground also. So there is no RS in this diagram for equivalent circuit because of shorted C2. So that's why di sini kamu short saja. So ya short circuit. So in order to get your punya voltage gain, you need to know what is your punya Vin and Vout, because AV is equal to Vout divided by Vin. So kamu punya Vout equation is GM VGS and RD and RL is in parallel, so you need to make it in series. So you punya equation is GM VGS RD in parallel sama RL, which is kamu punya Vout, and then Vn di sini is equal to VGS. So if you put inside the equation AV equal to Vout divided by Vn, you can cancel VGS di sini, and then yang tinggal is only GM. AV equal to GM in parallel, GM equal GM multiply dengan RD in parallel sama RL. So you obtain the AV equal to 4.244, which is nada unit. Kalau voltage gain ataupun current gain, there is no unit. So let's say for example di sini kamu kena suruh calculate what is your punya Vout, actual Vout. So in order to calculate ia punya Vout, AV equal to Vout divided by Vn. So Vout is equal to AV kali dengan Vn. Okay, so this is an example. Let's say kamu kena suruh cari what is ia punya Vout. So the voltage yang di sini kan Vn di sini equal to VGS. So if you look at this value di sini, VGS ini, this voltage yang ada di sini is equal to dengan Vn minus dengan VRS. Okay. So for example, kamu ada energy di sini, energy flowing kemari. Before you reach to this point, this energy already decrease. Ada macam loss, ada energy loss. So apa yang ada tinggal di sini is VGS equal to Vn minus VRS. RS yang itu ah. Okay. But for this example, kamu ada currentnya di sini. In order to use this equation, you need to know berapa current yang flowing in this one. Because IRS, baru kamu dapat cari what is yang punya VGS. Kalau nak ada current, you have an alternative way in order to calculate what is the VGS di sini is by using voltage divider rule, which is VGS equal to RG divided by RG plus RS kali dengan Vn. So dalam lab 9 kamu, the Vn di sini is given where equal to 100 millivolt. Okay. So RG divided by ini, then VGS in the end kamu dapat 90.91 millivolt. So you can calculate Vout equal to 90.91 millivolt, which is your punya Vin, kali dengan AV. So in the end kamu dapat 385.818 millivolt. Okay, some of you may ask, Vout di sini kamu ada equation also. Vout di sini you have equation. You can also use this equation to calculate what is your punya Vout. This one similarly, you can use both equation to calculate what is your punya Vout. Kamu punya Vout di sini will be the same as Vout yang di sini. If kamu punya Vout di sini and this yang ini is not the same, then there is something wrong with your calculation. It should be the same. Okay. So how do I prove again? This value of my analysis is correct. So you can use the multi-sim simulation software or you can use the practical. So based on my calculation, the Vn yang di sini I already connected using oscilloscope. So you can move this scale. So I want to check berapa peak value-nya of the VGS. So the VGS di sini it is stated 90.91 millivolt. So the one I obtained di sini is 90.91 millivolt. So it is the same. So what about you punya Vout? Vout I obtained 385 millivolt. So in simulation I got 364.412 millivolt. So this one is around the same value. The loss is only 20 millivolt. So I still consider this okay, because kamu punya supply is 100 millivolt, but the one yang kamu amplify is around 364 millivolt, and in analysis is 385 millivolt. So I have covered the transistor FET in self-bias configuration and also voltage divider bias configuration. So you need to try the tutorial in biasing the self-bias and the voltage divider bias. once kamu siap already the tutorial in biasing, you need to calculate ia punya AV ataupun Vout based on apa question itu require. So if you have any question, you can ask me in the class or anywhere during the school time. So that's it for now. So thank you and Assalamualaikum.